And welcome to the Daily Space Weather, a regular feature of the Smash News Network least busted name in news. We're coming at you from the galactic core today with some spectacular imagery. Coronal mass ejections here coming out of the southern hemisphere of the closest star, multiple in the past couple days. None appear to have any sort of Earth-facing components. Here's another wavelength from the same Solar Dynamics Observatory. We've got spectacular imagery today in various wavelengths. This is 335 plus 94 angstroms, a composite, two different ionic states of iron, and the ultraviolet emissions there. You can see some flares coming out of sunspot 2904 in the lower left. We'll show all kinds of zooms of that. Here are the magnetic fields in colorized magnetogram. This sunspot group has degraded. Will lose its name today. The only group we have is 2904. And check it out, we've got some additional close-ups here. Here's that same composite 335 plus 94 angstroms. Couple of flares happening there. Those are C-class flares, I believe. There's a close-up of that, and we'll show you even more of that toward the end of the video. Radio flux is only at 83 at the moment. Only 83 solar flux units. There is the one-year chart of the radio flux expressed as this black line here from Solon.info. And the Space Weather Enthusiast dashboard has been correct so far, and I've been incorrect in forecasting a coronal hole wind stream. So we don't see it arriving yet. I still say it's on the way. We're getting awfully low magnetic readings here. You see these fields here, BT of 3 and a BZ of -3. That is indicative of lots of plasma in between the sun and the Earth, in my opinion. But in any case, Space Weather Enthusiast dashboard not really forecasting a coronal hole wind stream. So whatever, we'll just keep our eyes out here. Let's keep an eye on it, pardon the pun. And before we do earthquakes, let me just check the life of the stream here. This video was originally streamed live to Twitch, again from the galactic core. If you hear that windy sound, that's what it is. It's just the galactic core, folks. All right, so no major earthquakes over the past 24. A bunch of earthquakes in southern Alaska. Check it out. Also, South Sandwich Islands continues to shake, so there is some activity there. Just no major quakes, and at least one coming in as we stream the video live. If you're wondering where it's streamed live, it was twitch.tv/smAsho. Maybe install the mobile app. It'll even alert you when we go live. And shout out to our compatriots on Twitch who stream about science. I think that might have been the largest quake of the past 24 there, a 5.7 at the South Sandwich Islands. Perhaps additional foreshocks showing up here, as that has been the location of many, many significant quakes over the past, over a month? 2 months or so? Maybe even longer. I'm really not a super big earthquake expert. We just cover it daily because of viewer interest. Little bit of geophysics. Very deep quake at Fiji. It's only a 4.6 magnitude. Couple of 5s here. There's a 5 at a 5.1 at Mexico. There's a 5.0 at Myanmar. Shout out to David Dubine. Drop us a line. Drop us a line, David Dubine. Kermadec Islands region with a 5.6. That's the second largest quake, I believe. So, a bunch of quakes around Alaska there, including 4.1, some Hawaiian quakes as well. Drop us a line if you felt an earthquake in the past 24 hours. I've never actually felt the ground shake and had it verifiably be an earthquake. It's on my bucket list. All right, so as far as volcanoes go, this is volcanodiscovery.com's Volcanoes Today page. La Palma is erupting. Oh my God. You hear that, Sagittarius A-star? La Palma. No idea how big of an ash plume it is. Don't fly your plane over the La Palma volcano. That's pretty good advice, I'd say. Suminosejima flight level 100. It's exploding and producing a 10,000-foot plume of volcanic ash. Semaru. Activity observed from the ground at Semaru, having been the largest volcano of the past few days, producing a 50,000-foot ash plume just a couple days ago there at Semaru, located on East Java, Indonesia. Nevado del Ruiz, 21,000-foot ash plume over Colombia from Nevado del Ruiz's explosive activity. Revenador exploding, flight level 150. That's in Ecuador. We've also got volcanoes erupting in Peru and central Chile. Intermittent emissions from Sabancaya, that's Peru. And central Chile exploding. Volcanic ash emitted from Nevados de Chilean there. Produced a 16,000-foot plume of volcanic ash. Flight level 160. Don't pole vault the caldera. Do visit the links. Do use the promo code Finish Line to save 20%, 25% through December 7th. So through tomorrow, you could always do your part. Maybe put your feet on the face of evil, the Fauci fraud bath mat, or the face of evil bath mat. Or perhaps you'd prefer to Mansa. Yeah, make America not suck again. And since America leads the way, that's part of the reason why Fauci has to shut up. Make sure you check our playlist, youtube.com/smashamash/playlists. There's a track entitled Fauci Shut Up. Or no, Shut Up Fauci. Anyway, shut up Fauci. If you're still listening to Fauci, I don't know why you're still hypnotized by fraud. We hope you snap out of your covidiocy soon. Stop worshiping at the cult of covidiocy. Again, use Finish Line as the promo code Finish Line to save 25% through December 7th. You can find links to our merch shop below this video as well as on our homepage, smashamash.com. Look for changes coming to the website soon. You hear that, Smash Staff? Also, we've been putting up public posts on the Smash team. It's not subscription only at the moment. The posts for the last couple of weeks here and through 2021 will be largely public. Now, we're only going to show you a teaser here, as our latest post is about acetylcholine. We're also putting our disaster report up there. Those are typically only for paid subscribers. And there are two basic levels as well as a paid-up annual option, which is by far the best. Let's get back to what's going on with space weather. Space weather! GOES magnetometer over the past 3 days there. We see a divergence in the readings from the GOES 16 and 17 at the moment. Another indication there's some plasma in between us and the sun. I still say there's a coronal hole wind stream on the way. Let's continue on to look at the current sheet. Earth has just snapped into a South Pole current sheet. And perhaps about to snap back into a North Pole current sheet. There's another current sheet showing up there. You can see that small North Polar region there. That's being measured by stereo A. See, this is stereo A right here. This is stereo B at Lagrange point 4. And if you're wondering where Nibiru is out here at Lagrange point 3. Just kidding, folks. There's no secret planet sneaking around in the solar system. People would see that. Here's the line of sight view. We may see a North Pole current sheet come. It's just that the magnetic environment can change suddenly. I won't try to forecast it this time. Next, the line of sight coronal hole plot. We're seeing some South Pole coronal holes making their way around here. And these North Pole coronal holes have retracted. You'll see right there some trans-equatorial North Pole ones, and then they're replaced by South Pole ones. So there's a bit of a magnetic indecision moment happening on the eastern limb of the sun. We've got a pretty well-defined one up here. That is North Pole oriented. Again, we're expecting some coronal hole wind from those North Pole oriented coronal holes that are just rotating out of view. Flare probability not all that high, although 2904 has been producing some flares, so it is beta gamma class. It's a beta gamma class sunspot. Sunspot 2904 is. And we'll take some high-res imagery of that toward the end of the video. Here's the flare profile, and you can see there was an M-class flare. There was a little bit of spikes in the proton flux. This is the photon flux in terms of X-ray wavelength. Photons. And here's the proton flux, particles. Mostly hydrogen nuclei, like 90% hydrogen nuclei. We saw a couple very minor spikes here around those flaring periods. Just a tiny bit of relativistic particles making their way to Earth. Very minor. Also, we're seeing a minor coronal mass ejection strike here, barely producing a blip. You can see a change in the temperature, the speed, the density, the phi angle, and the BTBZ all at once. Again, we're expecting to see the solar wind density pop up here in the next 24 hours. I still say there's a coronal hole wind stream on the way. We'll see what happens. Otherwise, pretty unremarkable. The conditions are about 6.5 protons per cubic centimeter for the density. Solar wind speed under 500 kilometers a second. They're at 483 kilometers per second. KP index at 1. It's a geomagnetic calm situation. So here's the last 4 hours of geomagnetism, magnetohydrodynamic pressure from Earth's geomagnetic moment in space. And this is largely showing you what happens when a proton makes it to the magnetosphere. It has to make a decision, folks. It's going to either slow down and bounce off and be reintegrated into the solar wind, or it might become part of this environment, in which case it has to pick a field-aligned current, which are around the poles like this, and be integrated into the underlying system, which is Earth's magnetic moment. I'm being vague on purpose because there's some chicken and egg stuff going on when it comes to this. Anyway, again, that's 4 hours of data. Here are ground magnetic perturbations, Earth's magnetic moment from the surface of the planet. This imagery is good at showing you where aurorae are likely to be seen, as well as during times of geomagnetic storm where power outages can happen, or are most likely to happen due to induced current into the power grids. And like the last frame, that's 4 hours of data. We'll let it play through a second time as we see some magnetic pulses coming out of the oceans here. The scale you're looking at here is nanotesla magnetic flux density. And let's continue on. And before I show the planetary forecast, I better take a look at the live stream, and it looks like it's just fine. Twitch is a fantastic live streaming platform, by the way. Check it out yourself. Maybe you'd like to make some videos like us. Hire us as a consultant. We'll hook you up. So here's where things are located in the solar system. Here's a forecast. There's where things will be on the 13th of December. Exactly 2 weeks before Christmas. That's not 2 weeks before Christmas. You'll be 2 days late. Anyway, next a star chart. And you can see Mars and the Sun there, having just rose here over Lehigh Valley, Pennsylvania. We're located at about 40.6 degrees north latitude here in Lehigh Valley. And the Sun will be passing through Libra and Virgo and Leo and setting in Gemini. Next, some views of those coronal mass ejections from Lagrange Point 1. The location of the SOHO LASCO C2 and C3, as well as the Discover and ACE spacecraft. Here's the LASCO C2 and C3. Also Mercury there. It's looking like it's hovering as it makes the turn. So great imagery there of multiple coronal mass ejections. They all appear to be off to the southwest of Earth, the west and southwest. And there's additional activity still occurring now. So this is not a complete event. There are still coronal mass ejections happening as we make the video, at least the last I checked. And let's do a cosmology segment. Cosmic rays. Let's talk about cosmic rays. We just saw a spike, at least at the Athens neutron monitor, so we're going to cover it. That's a 30-day chart there of cosmic ray flux from Athens. Neutrons. They have a very short lifespan because of beta decay, and that's part of what neutron monitors are measuring. And if you're wondering if if the sun is a neutron star, and that if it's powered by beta decay, the answer is no. It just isn't. Let's look at the Barentsburg neutron monitor. And we see missing data on the Barentsburg neutron monitor instead of a spike, which, by the way, is not an anomaly. It's missing data. Missing data is missing data. It's nothing to get frightened of. It's data that's not on the chart. Next, the Athens neutron monitor. There you go. There's the last 30 days at Athens. Pretty flat there at Athens over the past 30 days. Let's go farther south here. Here's Mexico City. A bit of an uptick there at Mexico City over the past 30 days. Let's go way north to Oulu. Yeah, Oulu, Finland. Shout out to our Finnish viewers. Shout out to all of our Nordic viewers. Shout out to all of our viewers, period. So there's Oulu. Oulu is seeing an uptick here over the past 30 days as well. And I would note the past couple years. You can see the past couple years here are pretty flatlined overall. So there's some oddities happening there. Some divergence from solar activity in some ways. Note how cosmic ray flux was higher in 2010 than it is now, or last year, or even at the last solar minimum around 2019. Let's go very far south to DOMB and DOMC Antarctica, and a ton of missing data there. A couple of weeks of missing data at DOMB and DOMC. So we'll ignore that and move on. Today's random object isn't random at all. It's Cygnus X3. One of the only known, if not the only known, cosmic ray point source. Of course, there are other suspects, but this one is known for a fact to be a cosmic ray source because of how it was originally discovered. I won't get into that. I'll save that for a different cosmology segment. Keep in mind what we're looking at here, folks, are not cosmic rays. These are X-rays, which are photons. Cosmic rays are primarily protons, mostly hydrogen nuclei, just like the solar wind, but containing all the rest of the elements as well. So let's take a look at this. This is an X-ray. And what's interesting about Cygnus X3 is it is a very massive object orbiting a very massive star. So it's a small, compact object orbiting a very large star. The star is so large, in fact, that if it were centered where the sun is, you'd be inside of it. It's about the size of Mars's orbit. It's a blue supergiant known as Deneb. It's also the brightest intrinsic object in the sky. There are stars that are brighter, however, those are closer. There is some argument as to the distance to Cygnus X3. Again, it does consist of two objects, and we're probably seeing the compact object right here. Also, keep in mind there is a disk of plasma in between the compact object and the Wolf-Rayet star. And one of those plasma jets is oriented directly at us. This thing has a periodicity of it's an eclipsing binary, so it has a periodicity of about 4.8 hours, and that's how it was discovered, actually, in the early 80s or late 70s, I think it is. If you want to read more about Cygnus X3, it is on the Neil Garrels Swift-Bat X-ray Observatory. It is entry number 948. Again, those are the hard X-rays from it. This is it in X-ray. A visual analysis from the XMM Newton. And let's see if the Chandra has it. Of course, it's got a great image there from the Chandra. Again, the brightest intrinsic object visible from Earth, Göbekli Tepe, is oriented at Deneb, the tail of the swan. And the soul stories about the storks carrying the babies to Earth and so on, that's all associated with this. This is one of the weirder stars when it comes to looking at what the ancients thought about it. And we're just going to bring up some radio frequencies here and see if we can see any structures. Again, keep in mind it's in the Cygnus arm of the Milky Way galaxy, so it's a pretty busy portion of space here. And so you're going to see all kinds of different funk in the different radio frequencies. It's what we call a high-mass X-ray binary, and there's all kinds of conjecture about what the orbiting compact object is. Some believe it to be a black hole, some believe it to be a quark star, and all kinds of other crazy ideas about what it might be. And that's a very zoomed out, that's the Cygnus arm, by the way. The Cygnus arm is a very bright arm of the Milky Way galaxy. I'm just going to get this in a better frequency here. I don't know why I'm in such weird... Look this in optical or something. And there it is on the pan-stars. That compact object, not particularly bright. Kind of a dark area around there, but some very high resolution, even like a spiral-looking feature there. That is not the most common thing you'll see, folks. Cygnus X3, the tail of the swan. You can read all about it on the forum also, on our cosmology forum. I'll show you that real quick. smAshomash.com/forum does have a cosmology forum there. You just click on that, and you can read all about Deneb. Let's talk about a less distant object here. It's the moon and the International Space Station superimposed on it. That's the astronomy picture of the day. Pretty high res. And you can go check it out yourself at apod.nasa.gov, the space station silhouetted on the moon. That's today's cosmology segment. Check our playlists for more if you like. Let's look at charging hazards. There aren't any. Electron flux is just at sort of moderate levels here. And we're just about to move into warning territory for the GOES 16. That's a 3-day chart. Here's the forecast model. And they are expecting a downtick here. I think it's going to be a more significant downtick. I think these are going to come down here because, again, I think there's a coronal hole wind stream on the way. What the heck? All right, let's move on. And next we'll show you the GOES electron flux. And allow me to vanish. Not that. Total electron content forecast. There we go. So GPS satellites, they have to communicate through a lot of electrons, and that produces GPS errors. The redder you see this blob, the more likely you are to have a GPS error if you're under that location. Total electron content forecast shows GPS errors, the most likely spots for them. And we've documented it well. Check out our Instagram page. There are posts about it at instagram.com/smAshomash. It's a reason to have your location accuracy turned on, to use Wi-Fi hotspots to help calculate your location. Next, we'll look at the ionosphere. This image here is showing you temperatures of different layers, as well as electromagnetic radiation penetration and chemical densities at different altitudes. Here's the Ionosphere layer and vibrational frequency. There's a lot of shaking going on up there above your head. A lot of shaking going on. One of the reasons why you shouldn't be frightened of things like CERN, but let's just leave that there. We do see some anomalies happening. So here's the anomalygram, departure in megahertz from the 30-day median. even as we approach southern hemisphere summer, we're seeing more high-frequency anomalies in the southern hemisphere and low-frequency anomalies in the north. Probably really not all that surprising. Again, this is anomaly in megahertz from the 30-day median. There's the latest ionogram, that's 12:45 universal time. And there's the anomalygram. You can see some low-frequency anomalies there over India and high-frequency anomalies over Antarctica. By the way, don't forget to check out our meteorology segments. We typically premiere those on YouTube before the daily space weather videos. And we stream them live to Twitch also. So I don't know if you're aware of that. Again, man, oh man, let me take off this headset. It's crushing my ears. It's crushing my ears, although the gravity here from the galactic core is just fine. Let's get to our bonus features. Speaking of bonuses, by the way, you can find links to this. You can even do a search for me if you want to buy a bike. I'll help you shop. If you simply type in curated Dan Nigro cyclist, you'll find me right away. First result there on DuckDuckGo.com. Dan Nigro from curated.com. If you want to shop bikes, also become a member of the Smash team once again. And again, meteorology segments are a regular feature on the channel. So check those out. We talk about the physics of, the physics of your weather and so on like that. How to forecast your weather, legit forecasts, models, and satellite imagery and all kinds of things like that. So here come the bonus features. Starting with the latest from Cerro Tololo. It's Cerro Tololo, Chile. Again, there's a bunch of filaments down here, and there are coronal mass ejections continuing. So there's going to be no lull in the action here for a little while. Should be exciting. I'm sure there'll be lots of imagery all over the place. Follow us on Twitter. There's lots of imagery on our Twitter feed. We retweet a lot of things. Twitter.com/SmashoMash. Exclusive content over there. Here's the latest 304 angstroms imagery. What's cool about the GO 16, folks, is that it has a wider field of view. So when we see large prominences in CMEs, they extend all the way out. This is all live here, so it's much better at showing prominences than the SDO, which has a narrower field of view and more detail, but less field of view. So here is the SDO imagery, and you can see it's a bit of a narrow field there. And we've got additional umbrae there. So this sunspot is increasing in complexity. 2904. It's looking pretty spectacular. As well as the southern hemisphere in general. So a bunch of filaments erupting there, as you can see. All basically harmless light shows that won't have really any geo effect at all on Earth, most likely. This is composite imagery, 171 plus 304 angstroms. Here's 304 alone. Yowzers. That's pretty good. What do you say, Sagittarius A-star? You know, folks, the nice thing about talking into the void is knowing that nobody's listening. Anyway, thanks for tuning in. Congratulations on realizing the channel exists, and may that solar wind be at your back.